Hello again. We're going to use Excel. In this case, we're not going to use the data set. The data actually has a menu for simple linear regression or for regression, but we're going to actually do it in a little bit easier way. So what we have here is we have data from our textbook example, which is just some imaginary GPAs that said a student got in high school, and then some imaginary first-year GPAs for the same student. This set of data is in order for the same student when they got to college, assuming that college is a little harder than a student who got a 3.5. In this case, they got a 3.3, 2.5. When they got to college, they earned a 2.2, and so forth. So some imaginary data, but a meaningful example. So what we're going to do is we're going to go to Insert Scatter Chart, Scatter Plot. And it's going to draw points for us for all that data. I'll explain in a second. And we can then go to the Layout Tools, go over to Trend Line. And what this is going to do is going to draw a line of best fit for us. So go down to More Trend Line Options. We want this to display the equation. This is going to give us our regression equation and R squared, which you've learned in a previous chapter. It's called the coefficient of determination. And we'll put these to use in a second. So it gave us our formula. I'm going to move the formula over here where we can see it. And you don't have to have it. You don't. All I want from you is this formula, because that's what we're going to use for some basic prediction. And it's only as good as the data, and it's only as good as our assumptions about how correlated these sets of data are. So what we have here again, the GPAs, and this drew a scatter plot for us, the y-axis being GPA starting from 0 all the way up to 4.0 for high school, and then GPA 0 all the way to, in this case, 5.0 for first year of college. So what we know about correlation is that these two are probably correlated, and there's definitely a linear relationship when you just look at these dots. But what the computer did for us, what Excel did for us, is it drew a line of best fit. If we were to draw an imaginary line through all these scatter points, what point or what line would correspond with each of these most closely? So we have one over here, but mathematically it figured out then that line of best fit. And your book gives you a couple of equations to do this, to figure out the slope of the line and then that y-intercept. What we're basically doing is, if you go to prove this, you have to do some really hairy calculations, and it involves distributing some algebra and simplifying, distributing again, then taking derivatives and then distributing and simplifying, and that you get to basically proving that this works. We're going to take it on faith and just say that this equation corresponds to what we know in algebra as the slope-intercept formula, where in this case A would be where this line would intersect with the y-axis, B being rise over run slope of the line, and x being our independent variable. And so to solve for then y, this dependent, y is dependent upon the value of x, and then we have then the slope, and we have where it would intersect y. So where it intersects y, you then add to that this b variable, the rise over the run, times our independent variable. In this case, the independent variable then is this high school GPA. So what we're able to do, and this corresponds with the example in your book, is we're able to take a given GPA. Let's just say if somebody earned a 2.8 in high school, what might they get given this data of average student performance their first year in college? And so you can take then this 0.7198 plus whatever you get when you multiply 0.7039 times 2.8. And that's how this formula works. And if you read along in your book, what you'll see is they came up with a 2.69. So work that out. We carried a few more decimals here in Excel than what your book shows, but this is a simple way. This is how I want you to do it. This is a simple way then to get that equation. R squared corresponds with how closely this line fits that data. As you know, the variable R stands for, it's our correlation coefficient, correlation between these two sets of numbers. You square that, and then that tells you basically where they overlap. That tells you, in this case, how closely this line resembles this data. And in this case, where it's about 50-50, 0.4671, because the data was pretty variable, a lot of variation in this data. But this would be the line that best fits, and Excel did it for you. See you on the other side.